Right, grade 12s, I want to continue with a further discussion on average gradients. And what I'm going to do is I'm going to give you the graph of a parabola y equals a quarter x squared. And I've got a whole lot of points on this parabola. And notice as well that you've got a straight line y equals x minus 1. There's actually touching the parabola at point A. And I'm going to color code that point A because that's going to be a very important point in our discussion. Okay, and you'll notice that well, if you drew both graphs, you're going to notice that the line y equals 1 is a tangent to the graph of the parabola. Tangent means it's a line that touches at one point only. Now notice if you take points A and B, those would be two different points on the graph of the parabola, and if you join those 2 points you would be able to work out the gradients of the line AB, which would in turn give you the average gradient of the parabola between those 2 points. Now what I'm going to do, I've actually physically chosen certain x values. If you look at x equals 2, how did I get the corresponding y value? Well, pretty simple. What I actually did is I substituted it in. So I said, if my x value is 2, what would my corresponding y value be? Well, 2 squared is 4. And if you multiply by a quarter, you get 1. So that gave me the 1. And then I chose 2, 3, 2, 4 for x, 2, 5, and then 3. So I'm working in the interval from 2 to 3. Okay. And what I want to do is I'm going to investigate the gradients of the line segments that are joining AB, AC, AD, and AE, and I'm going to see where the average gradients of these little line segments are going. We're going to be looking at the gradient of the tangent line, and what we're going to do is come up with an incredible formula or discovery about the gradient of a parabola. We know the gradients of a line, but what about the gradients of a parabola? So let's start by looking at the average gradient of the parabola between A and B. So we're going to look at the average gradient of the graph between A and B. Okay, so here we go. So let's look at between A and B. There we go. Now what would be the point A? A is the point 2 and 1. And if we look at B, B is the point 3. And that will be 2, 2, 5. Obviously, you substitute the x equals 3 into the equation to get 2, 2, 5, but I've done that already. So let's have a look. What would be the average gradient of the parabola between those 2 points there? Okay. All right. Well, it's easy. It's the gradient of the line AB. So the gradient of line AB, which is the average gradient of the curve f. Remember, f is the parabola. Let's call it f there for an abbreviation there. And that's going to be simply the difference between the y's, 2, 2, 5, subtract 1, divided by 3 minus 2. And you can work that out and verify that it's going to come to 1, 2, 5. And I'm going to circle that value. Okay. Now let's have a look at if we take the points A, which is 2, 1, and let's look at the point C. Okay, now what is C? C is the point 2, 5, okay, and 1, 5, 6, 2, 5. Let's just verify that. There it is there. So here's the point A and C. And what we're very keen on looking at is what is the average gradient of the curve between those 2 points. Now notice you've got the black line and the pink line, and the gradients are changing. Obviously they would change because the points are moving closer and closer to A. You notice B is there, C is getting closer to A, D, and then eventually E, and then we will then overlap, and we'll have the tangent to the curve at that point. But let's just get the average gradients here. So what would be the gradient of the line AC? Well, let's see. That's going to be the average gradient of f again between those 2 points, which will give me 1, 5, 6, 2, 5, subtract 1. That's the difference between the y's. And then you've got 2, 5, subtract 2. And this will come to about 1, 1, 2, 5. Okay, there we go. All right, now let's go and have a look between A and D. What's happening between A and D there? Okay, so let's go to another color. Let's look at the point A and D. Okay, now what is the coordinates of A? Is 2 and 1. And point D, well, if we look at D, D is the point 2, 4, and 1, 4, 4. Okay, now let's get the average gradients, which is the gradients of AD, would be the difference, if you say the y, that y minus the 1, over that x there, which is 2, 4, subtract 2. And if you work that out in a calculator, you're going to get 1, 1. Let's circle that. Okay, what's the other point? Let's look at A and E, which is these 2 points, and obviously the points are getting closer to A, but the gradients are changing. So if we have a look, maybe we can use another color here. Let's go to red. Okay, maybe you can use some red. Okay, now let's look. There's the point A is 2 and 1, and the point E, if you look at it, is 2, 3, and 1, 3, 2, 2, 5. Okay, what is the gradients of AE, which is the average gradients again, would be 1, 3, 2, 2, 5, subtract 1 over 2, 3, subtract 1. Work that out and you'll get 1,075. Look at that there. Alright, so we've got differing gradients there. Okay, now I want you to notice something. As we start at B, the points are moving down the curve all the way to A. The x values were 3, 2, 5, 2, 4, 2. They're getting smaller, the y values are getting smaller, but we want to know what are the gradients, the little gradients doing, okay, as the points move closer. Well, let's see. Okay, what we can do is, let's just have a look at this. If we take the points, we'll summarize the information quickly. Let's have a look. If we take between the points A and B, and then we can look at the points A and C, A and D. Let's summarize all this. A and E. Okay, what was the average gradient between A and B was 1,250. Between A and C was 1,125. Between A and D was 1,100, and this between A and E was 1,075. Now, what do you notice about these average gradients, or the gradients of those line segments between those 2 points? They're approaching, and it looks like, look, it's 250, they're 250, 125, it's getting smaller. I think it's going to approach 1. Okay, as we get closer and closer. Remember what's actually happening. If you look at these points too, the distances are getting kind of smaller between the 2 points there. You can see they're getting smaller, and I'm going to summarize that in a moment too. But interestingly, as the points move closer, I'm going to just redraw this here. As we move closer, let me just draw another picture here quickly. If you take it, I'm going to draw it fairly big. There was your parabola. Okay, it came like this. Okay, now you've got the point A there. Now look at this, A, and there was the x value at 2. Then you had B here, and that x value was 3. So the distance here, you'll notice that that distance is actually 1. Okay, now we had the point we had the point C. Okay, and the x value here was 2, 5. Okay, not quite accurate there, but let's go 2, 5. It's not really to scale this. And then we had, so the distance between those 2 points would now be, if you think about it, 0, 5. Then we had point D. Okay, and the distance, the x value there was 2, 4, and the distance is now getting really smaller. It's 0, 4. So do you notice that the distance between the 2 points, as we move from point B to C to D and then eventually to A, where you get that tangent line. Okay, remember we started with a line segment going there, and that was between 2 points. We got the average gradient of the curve F between those 2 points. Now notice the distance between the points is getting smaller, and in fact that distance that we can call H is going to 0. The distance, the H, which is really the distance between the 2 points, is getting closer and closer to 0. So it's distance between the points. Okay, so the distance, so there's two things happening. The distances are getting closer to 0, but the average gradients are also changing. And where they're going, what is the equation of the tangent line? Look at this. What's that equation? It was given to us, have a look there. It was given to us as y equals x minus 1. If you physically draw the parabola and the line, you'll see that they intersect at 2, 1 there. Okay, so, but don't worry, we're not going to go into that. I just want you to accept that at the moment and say, well, okay, what do we know? The gradients are approaching the gradient of the tangent line 2f at x equals 2. Now, people, we in the next lesson on calculus, we're going to be exploring this concept of average gradients as they change, and we're going to develop a formula for the gradients at a. Okay, this is different. The only thing I want you to remember now is, listen to me carefully, is that you've got a whole lot of points on the graph. Okay, you can work out the gradients of the line segments joining those 2 points, and of course you then have the average gradients of the parabola between those 2 points, and those gradients, or those average gradients, are going to, or tending towards 1. But do you notice that the gradients of that tangent line, this line here, at 1, or at 2, the gradients of those tangent lines at 2, the gradients of the tangent at 2 is the same as the gradients of all of these line segments as they move down. So just to clarify that, the average gradients are going to 1 as you join A to B, A to C, A to D, and they all tend towards the gradient of the tangent line, which happens to be 1. Okay, it's the coefficients of x, it's the gradient of that line. This line is y equals x minus 1. And this is the parabola. So, this concept of moving gradients and the distance between the points, as I've shown you here, which is going to feature heavily in the next lesson. So, as the average gradients change and the h's go to naught, the distance between the points go to naught, we're seeing something, those average gradients are tending towards the gradient of the tangent line.